So hey guys, there are two types of diffraction phenomena. One is Fresnel diffraction while the other is Fraunhofer diffraction. In Fresnel's diffraction, we see the source or screen or both, that is both the source and the screen are at finite distance from the obstacle, while in case of Fraunhofer's diffraction, we see that the source of light and the screen are at infinite distance from the obstacle. So we can say that in Fresnel's diffraction, distance matters, while in case of Fraunhofer's diffraction, inclination matters. So, in today's topic, we are going to learn Fraunhofer diffraction and we are going to derive Fraunhofer diffraction due to a single slit and its intensity calculation and graph plottings and all. So, please watch the video till the end. So, let's start the topic. So, now we are going to study Fraunhofer diffraction due to single slit. So, to understand this concept, we must know what is a single slit. A slit is a rectangular aperture whose length is large as compared to its breadth. The width of slit should be at least comparable with the wavelength of light but never less than wavelength. This is the main concept of a slit width. So, we have taken B as a slit width, that is the point or the distance of OL. Now, for the mathematical analysis, so we must know at which principle it is based on. It is based on the superposition of high-gain secondary wavelength which are supposed to be generated at every point of the wavefront when it occupies the plane of the slit. So, what we have laid? We have laid OP, this point OP as R, and this point LP as rho. So, and if we notice in triangle LOM, that means this portion, I am putting a zoomed version of this. So, a triangle LOM, what we can find OM, this portion OM is y. First of all, OL is y. What is y? Y is the distance from the central maximum. So, for this case, OM is the sine theta component of OL. That is, OM is y sine theta. So, we can say OM equal to y sine theta, OP equal to R, LP equal to rho. So, if we now watch carefully that what is LP? LP is OP minus OM. So, we are writing LP as OP minus OM, that is LP means rho, OP means R, and we have seen that OM is y sine theta. So we can say rho equal to R minus y sine theta. Now if we take a elemental strip from this point, suppose the elemental strip be dy. Okay, so for first of all, we need to know the displacement of point P. So let displacement of P. So we will let a displacement of the point P. What we will let? Let a variable, suppose z naught, means z at its initial value, that is a sine omega t minus k rho. So what is A? A is the amplitude. So now we will study the wavelength from with dy to reach P at amplitude A dy. So that means when wavelet from with dy reach p at amplitude at what amplitude? At amplitude a dy. So we can write for small value dz equal to a dy sine omega t minus k rho. So as we can see, this is that is the z naught is a shm displacement of a shm particle. So as we know, so uh, we can say omega. What is omega? Omega is the angular velocity. So we know omega equal to 2 pi by t, and k is equal to, we know, 2 pi by I am doing over here, k equal to 2 pi by lambda. What is lambda? Lambda is the wavelength, we know. So we can say, or rather, if we integrate the function z from this point to this point, that is from the limit minus b by 2 to plus b by 2. So what we can see, that is z. So z equal to integration of a dy sine, I am putting the value of omega and k, so that will be 2 pi by capital T into t minus 2 pi by lambda into rho. We can say that. Now from where to where I am integrating? I am integrating from point minus b by 2 to 2 plus b by 2. So my lower limit will be minus b by 2 and upper limit will be plus b by 2. So now what we have seen earlier, that rho is equal to r minus y sine theta, that is, we can put the value of rho in this equation of z we are getting. So as we can write, so what we can write, minus b by 2 so to b plus b by 2 a dy sine 2 pi by t minus 2 pi by lambda. What is I can write in, I will put the value of rho over here, it is r minus y sine theta. Okay, so what we can write, we can write minus b by 2 to plus b by 2 a sine 2 pi by capital T minus 2 pi by lambda r minus 2 pi sine theta y by lambda in, so ty. So we can write it like this. Now we know what we know, that I will first of all integrate this sine of I mean the first I will integrate the sine functions. So this portion, that is the 2 pi by capital T minus 2 pi by lambda into small r, we can treat it as a constant alpha, And as we're integrating with respect to function y, so this can be written as, this all can be treated as another constant beta. That means what I want to say, that if I let this alpha and this portion as a constant beta, what we can say, as we know, as the basics of integral says, so sine integration of sine alpha minus beta y, if we say, what does it gives? It gives minus cos alpha minus beta y by differentiation of this inside function, that is will be minus beta. So what we can say, this cos alpha minus beta y by beta, as the minus is getting cancelled. So now what I can write, that means this constant function, that is this which I've let beta, will come out as its reciprocal. That means here it is that a, I'm putting a, and this the reciprocal of whole this, that means a lambda 2 pi sine theta. Okay, now what I am getting, then I will put this overall function, that is this one. So as the minus minus get cancelled, so what I can write, that is cos what, 2 pi by t into small t minus 2 pi by lambda r minus 2 pi sine theta lambda y dy, not dy, as we have already integrated, sorry for that. So what will be the limit from b by 2 to minus b by 2. So what I will look over this. So what I will do now, I will put the value of b by 2 in the places of y. So what I am getting, so I have put the value of the upper limit, that is b by 2 and minus b by 2, and what I am getting over here minus pi b sine theta by lambda, and over here plus pi b sine theta by lambda. So now if we take minus common from whole of this function, that is it will be minus a lambda by 2 pi sine theta, and this is the function. So what is this? This is cos, and let this be a, and this also be a. That means that what can we say? That is cos a plus b minus cos a minus b. And as we have learned in 10 plus 2 trigonometry formula, what we have learned, that cos a plus b minus cos a minus b is minus 2 sine a into sine b. So so now this 2 and 2 will get cancelled, and minus into minus becomes positive. So what can we write? We can write a lambda by pi sine theta into sine pi b sine theta by lambda into sine 2 pi by capital T into small t minus 2 pi by lambda into r. So now we will generalize the formula. For generalization of formula, what we will do, first of all, we will multiply it with Slit weight at both numerator and denominator. That is a b by pi sine theta by lambda. We can write like this as the denominator as lambda goes here. So this means same, and I have multiplied with another b, so it will be like this. So and then we will put the expression, that is the sine function. um, so I'm putting it. So now we will let, what we will let, we'll let this function suppose be alpha. That means let pi be sine theta by lambda equal to alpha. Okay, so what can I write? You can write Z equal to AB into sine alpha, as this will also be alpha, this and this is same, sine alpha, and this is also alpha, that is by alpha. And we will write the rest of the thing, 2 pi by capital T into small t minus 2 pi by lambda into r. Now we can say, what we can say, this AB sine alpha by alpha as amplitude A, and this one as a wave, as we have earlier let it as a wave function, so we know. So now what we can say, that I we also know, as we're calculating the intensity, we know that I equal to a square, that is square of amplitude is equal to the intensity I. So I can write I equal to AB sine alpha by alpha whole square. So that is what I can write, AB whole square sine square alpha by alpha square. So what I can let AB whole square be I naught. So that is the initial intensity. So I equal to I naught sinus square alpha by alpha square. So thereby we have derived the intensity formula for single slit diffraction. So what, where I is what, intensity, where I is intensity, and alpha, what is alpha? Alpha is pi b sine theta by lambda, and b is slit width, and theta is angle of diffraction. So hereby we can say that the formula for the intensity of single slit diffraction is I equal to I naught sinus square alpha by alpha square. So now what we will see, we will see the conditions for maxima and minima for a single slit diffraction. As we have derived the intensity formula, I equal to I naught sinus square alpha by alpha square, where alpha equal to pi b sine theta by lambda. Now we have studied for the cases of maxima and minima in mathematics that for finding maxima and minima we need to differentiate and we have to equate it equals to 0. So for I need to find a maxima and minima for what? For I need to find it for alpha. So I am doing, so I am differentiating it, that is di by d alpha equal to 0. So this is the first condition for a function to be know that whether it is a maxima or a minima. So we have differentiated by using that u by v rule. So what I have done after I am getting this by using u by v rule. So what I have done, that I have taken alpha common, and that was alpha raised to the power 4. And what I've done, that after I have cancelled the coefficient and the denominator becomes alpha cube. Now in the next step, very next step, what I've done, I've taken 2 sine alpha common, and it became 2 sine alpha in bracket alpha cos alpha minus sine alpha. There we get two equation, that is sine alpha equal to 0 and alpha cos alpha minus sine alpha equal to 0. So for now, what we will do, we know for a maxima or a minima conditions, we need to do a double derivative test for knowing whether it's a maxima or a minima. So when I do a double derivative test for this function, that is sine alpha, so that is d square I by d alpha square gives cos alpha, which is greater than 0, and for this one I get minus alpha sine alpha, that is a negative, so which is d square I by d alpha square less than 0. So when the double derivatives gives a positive value, we say it for the condition of minima, and when the double derivative test gives a negative value, we say it for the condition of maxima. So from the minima we get, so we can equate that sine alpha equal to 0 equal to sine plus minus n pi, as we know that every integral multiple of pi under sine function gives 0. So we can say alpha equal to plus minus n pi, and as we have already know that alpha equal to pi b sine theta by lambda equal to plus minus n lambda, we can also say that b sine theta equal to plus minus n lambda. So as we have seen, for the maximum condition, what we are getting, alpha cos alpha minus an alpha equal to 0, that is alpha equal to tan alpha. So we are getting this equation in the maxima case, and we will now see the graphical method for determining the roots of this function, that is alpha equal to tan alpha. So now we have roughly plotted the graph, and we can determine the roots of the equation, that is tan alpha equal to alpha. So as we can see, this is the graph for the tan alpha, and the from the origin there has the graph of y equal to alpha, we can see. Now we know I formula for intensity I equal to I dot sine square alpha by alpha square, and and from these points we are getting the point of intersection, that is for the alpha 0 plus minus 1.43 pi plus minus 2.46 pi and so on. So we can say that at alpha equal to 0, what will be the intensity? So at alpha equal to 0, if we see, that is I equal to limit, as it is we cannot directly put 0 by 0, so we need to use that alpha is tending to 0, limit of alpha tends to 0, I dot sine square alpha by alpha square. And from standard limit we know that limit x tends to 0, sine x by x is 1. So for this case, this will also be the same, that this portion will become 1. That means at alpha equal to 0, we get the value of I dot. Similarly, at alpha equal to plus minus 1.43 pi, if we see, That means if we put the value of 1.43 pi in the formula, we get approximately I equal to 0.0469 times of I naught. So by this we get for same case for 2.46 pi, 3.47 and so on. So roughly we have seen these two cases. So this is all over what is there in the topic, and another graphical measurement is left, that is the intensity distribution due to single slit. So this is the intensity distribution graph due to single slit, where the graph is between the intensity I and alpha. We know that alpha equal to pi b sine theta by lambda. So for every value of alpha, that is from pi to pi 3 pi, and the point I1 is the secondary maxima. And that's all for today. Thank you for being a part of this lecture.